With this problem, we are going to apply everything we've seen in several videos. First, I want to actually go ahead and add an arrow on the bottom left of this graph because I think that'll help with consistency for us. All right, so the domain of this function, it appears to continue indefinitely to the left, but stop on the right at 5. And it looks to be a closed dot, so the domain of this would be minus infinity to 5 with a bracket. That's again going in the x direction. Going left to right, we see that. Well, if we look going in this direction, the lowest this function gets is minus infinity. The highest it gets is a positive 3 right here. Positive 3. And it appears to be included there. X-intercepts. We appear to have 2 points here that are x-intercepts. That would be -1, 0, and the point 5, 0. All right, next we have f of 2. Well, that'll mean we look at an x value of 2, find where this is, and that appears to be where that maximum is. So that should be a value of 3. Now, based off of that being a maximum, in fact, let's go ahead and label this. That is a relative maximum at the point 2, 3. And depending on who you ask, looks to be a relative minimum. I would call this a minimum, is at the point 5, 0. Some textbooks might not refer to endpoints like that. All right, now, based off of those two things, we can determine the increasing and decreasing behavior. It is increasing from minus infinity, and we have a maximum at 2, so it changes direction there. And then from 2 over to 5, it decreases, and since that's the end of our domain, notice our domain here goes from minus infinity to 5. Minus infinity to 5 is our domain. Last thing is find values where f of x is equal to -5. So I'm going to start here at my y value being -5, and I only have one value right here, and that appears to be at an x value of -3.